Here are our two topics for today. We're going to talk about double time and half-life. Double time means how long does it take for something to double. For example, in this case, we're talking about population right here. How long would it take for the population to double in these particular countries? Well, you can see here in Brazil, it's that light purple, it's going to take 40 to 50 years for their population to double, or to become twice the size that it is at the current moment. What about half-life? Half-life is usually having to do with drugs, some sort of drug in your body, like let's say Advil. Let's say you take 40 milligrams of Advil, and after one half-life, you're down to 20 milligrams. And that half-life could be something like 6 hours. It could be, in other cases, sometimes like hundreds of years. But it's that amount of time that it takes to half the amount of drug in you. And the doubling time is the amount of time it takes to double the population in our particular example. Here are the definitions. Doubling time is the time required for a quantity to double, and half-life is the time required for a quantity to decrease in half. And again, we usually talk about doubling time with population and half-life when we're talking about drugs. Here's the double time formula. So the new value, the amount of, say, the number of population, the population will be equal to the original population times 2 to the t. This is number of years. And this would be our double time. So get that down, please. And we'll use this and you'll understand it more once we do a problem. Okay, here's our first problem. The world population went from 3 billion in 1960 to 6 billion in 2000. So do you see how that doubled from 3 billion to 6 billion? And that means that our population doubled in 40 years, because 1960 to 2000, that's 40 years. So we can say that our t sub double, we say sub because it's going to the bottom, our double time is equal to 40 years. It's taking 40 years for the population to double. Now, if the population right now in 2020 is 7.8 billion, well, that's going to be my initial value. What will the world population be in 27? Well, that means my time is equal to, how much time has elapsed? If we're talking about from 2020 to 2070, well, that's going to be 50 years, right? Just subtract those two values, and that's a 50-year difference. And I chose that value because that's about the time when you guys are going to retire. So let's think about when you retire, what's the world population going to be? So that's what it's asking. What will the world population be in 27? So our new value, or in this case, our population in 2070, is going to be equal to our initial value, which is 7.8 billion, times 2 to the t over t. Well, my lowercase t is the number of years that we're talking about, divided by our double time. Okay, our double time is going to be divided by 40. Now, when you put this in your calculator, folks, you have to remember your parentheses. If you don't, you will absolutely get this question wrong. So pick up your calculator right now, and let's all confirm that you can get the right answer. I got new value is equal to 18.55 billion. And make sure you get the same answer as me, please. So we're basically saying that the population is going to do a little bit more than double, which makes sense, right? Because we're talking about 50 years, which is more than the double time. So we are doing more than double. So crazy to think that when you guys retire that the population could be that high. All right, next one. The U.S. population has a doubling time of 75 years. That is true. If the population right now is 328 million, also true. What's the population in 2045? All right, well, our new is going to be equal to our initial value, which is 328 million, times 2 raised to the power of lowercase t. Well, how many years are we talking about? We're talking about from 220 to 2045. So that's a difference of 25 years. So we're saying in 25 years, what's our population going to be? Now we're going to divide by our double time right here. Okay, what is our double time? Well, it says the doubling time is 75 years. So again, go ahead and put that in your calculator. Make sure you're putting parentheses around your exponents there. Unless you have that newer calculator and you really don't have to do that, because it puts it all the way up into that exponent. It's good practice to do it though. Well, I get 413.25 million people, which is a lot of people. You might want to be buying real estate because a lot of people need to live somewhere. All right. Now let's go ahead and talk about half-life. This is our half-life formula, and you might notice it's literally exactly the same, except we're replacing the 2 with the half because it's halving, right? As opposed to the other one was doubling. So let's go ahead and do this problem. Carbon-14 has a half-life of about 5,700 years. This builds up in living organisms when they are alive. Once the organism dies, the carbon-14 starts to decay. All right, so if a dead squirrel, sweet, has 50 milligrams of carbon-14 in it the day it dies, how much carbon-14 will remain in the squirrel after 200 years? A little creepy to think about. That's all right. The new amount of carbon-14 is going to be my initial, which was, what's my initial? 50 milligrams. That's how much we have of carbon-14 to begin with, times 1/2 raised to the power of t. T is my amount of time, and in this case we're talking about after 200 years, divided by our half time, or our half-life, 5,700. Now, I highly recommend putting the 1/2 as in a 0.5. If you want to put it in 1/2, that's fine. Just make sure you put it in parentheses. Okay, so I recommend doing 50 times 0.5 to the 200 divided by 5,700. Just make sure you have that in parentheses. All right, go ahead and do that on your calculator. Let's all make sure that we are getting the same answer. I get 48.8 milligrams, which makes total sense, right? Because it takes 5,700 years to get to half. Well, half would be 25 milligrams, and since it's only been 200 years, it's not going down that much. So a little creepy to think about. All right, next one here. The half-life of Tylenol, I'm not even going to try to pronounce that one, is about 2.5 hours. That is true. If you take an 800 milligram dose, how much is in your body after 10 hours? Well, the new amount is going to be your initial, which is 800 milligrams, times your 1/2, and I'm going to write this as 0.5 because it's easier in my calculator. And that's going to be raised to the number of hours that we're talking about, and that's 10 hours, divided by my half-life, which in this case is 2.5 hours. So again, try this in your calculator. Make sure you're getting the same thing as me. I recommend putting parentheses around that 10 divided by 25, and I get 606.3 milligrams of Tylenol. All right, ladies and gentlemen, basically we are just applying these two formulas. I hope you enjoyed yourself and have a fun time doing practice on this. We've got an optional quiz coming up shortly on it. Bye.